In this video, we'll be investigating binomial distributions. Two essential questions. One, what are the criteria for a binomial distribution? And two, how do we calculate binomial probabilities? A binomial distribution will have these four characteristics. Number one, there will be two outcomes. And our outcomes, we will call them success or failure, and this is arbitrary, really. It's what we're counting. It's what we're counting. This success might be an instance of cancer. Certainly the person having cancer would not consider it a success, but it's what we're seeking. This is often called a Bernoulli trial. After there's a family of mathematicians named Bernoulli, and it's named for one of those, Daniel Bernoulli, as a matter of fact. Number two, there will be a fixed number of trials. Number three, the probability of a success will stay fixed. And we'll call this probability P. Number of trials, like our sample size, will be N. And lastly, the trials are independent. You might think this is closely related with number three. You know, the outcome of one event gives us no information about the outcome of the next one. Okay. An example of a binomial distribution. Let's say we are taking a 5-question multiple choice quiz. There are 4 answer choices. And we are guessing. We have no earthly idea what's going on this thing. All right, let's check our 4 outcomes, our 4 characteristics, that is. Are there 2 outcomes? Yes. On any individual question, we're either going to get it right or wrong. There's a fixed number of trials. In this case, N is 5. There are 5 multiple choice questions. The probability of success is constant. Well, there are 4 possible answer choices, so we have a 1 in 4 chance of getting any one right. And the trials are independent. How we perform on question number 1 is going to have no impact on question number 2 or 3, vice versa. So on. The trials are independent in this case. So this situation is binomial, and we write it in this fashion. We say it's a binomial with N trials and a P probability of success. So for our particular example, it's a binomial, 5 trials, and we have a 0.25 or 1/4 chance of success. This is the notation. You can see that it's a little bit similar to our normal notation where we have cap in and we have a mean and a standard deviation. Here, the 2 parameters of interest are the number of trials and our probability of success. Well, what kind of questions would we hope to answer, and how might we answer them? We're going to need a formula for this particular probability. Formula. This can be found on your formula chart and also page 419 from our text. This formula is going to look a little bit intimidating in the beginning, perhaps, but you will see that it makes sense, and also there'll be a calculator function that's going to help us get there. We will say the probability that our binomial variable x is equal to some number x, cap x and lowercase x here, is equal to n combination x times the probability of success raised to that power x times 1 minus p, that's the complement, to the n minus x power. Okay, what are all these letters representing? Well, this n we've already discussed. N is a number of trials. This p is the probability of success. And this x, this lowercase x, is how many successes out of that n. Number of successes out of n in n trials. Okay. This little factor here is called a combination. It's sometimes called the binomial coefficient because it's the number that's multiplied by this term over here. Also called the binomial coefficient in this context. Alright. And this n choose C, pardon me, this capital C here, and then a little n and a little x, subscripts on both sides. It is equal to n factorial, and this little exclamation point is that integer times all the integers below it down to 1. We've talked about this previously. Divided by x factorial times n minus x factorial. Okay. Let's go ahead and use this for a particular instance for our situation. So we have our binomial random variable. We're guessing. We got a 5-question multiple choice quiz, and we're guessing. All right. Let's say I want to find the probability that x equals 1. Okay. What I'm saying here, what is the chance we get exactly 1 right? That's my question. My random variable x is the number that I'm getting correct on this quiz. All right. I want to know what's the chance of us getting 1 correct. Well, let's start substituting into this little formula here. So I say probability that x is equal to 1. Probability that x is equal to 1. This n is the total number of trials. This x is how many we want correct. So in this case, n is 5. This little symbol C. This x here is 1. Times P, our probability of success. So in our case, 0.25. That's the chance that we guess correct. X is how many we want. Again, it's this value, it's 1. Times 1 minus P. Well, that's 1 minus 0.25. In this case, that's 0.75. This is the chance we fail. This P is the probability of success. This 1 minus P is its complement, the probability of failure. To the n minus X, this is 5 minus 1. It's 4. So what we see here is we'll have one correct response, 0.25 chance of that happening, 4 incorrect responses, 0.75 chance of that happening, times this particular number. So let's come up here using this formula and see if we can figure it out. Well, n factorial is the total number of numbers, 5 factorial, the total number of trials. X factorial, that's our number of successes, 1 factorial. And this is 5 minus 1, or 4 factorial. Well, hope you see 1 factorial is just 1. So what we're left with is in the numerator, it's 5 times 4 times 3 times 2 times 1. And the denominator is 4 times 3 times 2 times 1. Well, 4 cancels with 4, and 3 with 3, and 2 with 2, and 1 with 1. So this entire factor here, combination of 5 choose 1, is simply 5. So what we're left with is 5 times 0.25 to the first, I don't need to write to the first, times 0.75 to the fourth. Use your calculator and find this value. It is approximately 0.396, or that is 39.6%. So let's think about that a second. Does it make sense that about 40% of the time we will get exactly 1 right? Well, I'd say that's reasonable. We know we're going to be getting 1 in 4 of them correct on average. And if we have 5 questions there, we're going to get exactly 1 40% of the time. That just feels like a reasonable number. Sure, sometimes we won't get any right. Sure, sometimes we'll get 2 or more. But doesn't it seem that the most likely outcome would be 1? So to say that we're going to get that 40% of the time seems like just feels like a pretty good number. This is not for your notes. This is just to think about. I want to see if I can explain where this particular line is coming from. Okay, so we're taking a multiple choice quiz. There's going to be 5 of them. So I'm just going to write 5 blanks. Okay, we're going to consider this 5-question multiple choice quiz. Let's say that I managed to get this first one right. I'm going to call this a success, and I missed all the rest of them. So we have a success and then 4 fails. Well, what would this particular outcome, what would the probability look like? Well, the probability of success is 0.25. The probability of fail is 0.75, and I would have 4 of these. And this is an AND situation, and since they are independent events, it does make sense that I would multiply. So I just multiply all this together, and I would have this outcome. Well, you can see this is 0.25 times 4 of those. So this is 0.25 times 0.75 to the 4th power. Well, that's exactly what that says there. Well, what's the deal with this 5? Well, sure, we could get the first one right and then miss these other ones, but couldn't we also miss the first one and then succeed and then fail? And wouldn't this probability be the same because these orders are switched around? But couldn't we also fail, succeed, fail? How many ways could we write this? Well, it turns out there can be 5 because you can see that our success could be in any one of those potential positions. So what you see here is, sure, any one of our outcomes would look like this, but we can write this situation 5 different ways. So this number in front, this combination, is simply finding the number of ways that we can rearrange this situation so that it fits what we have. So it's 0.25 to the first, 0.75 to the fourth, but there's 5 different ways that we can do this. Now I'm going to look at the TI-84 calculator command that can help you with this situation. It's called Binomial PDF. Let's see if we can find it. From your home screen, you will hit second and then vars, pulling up distribution. This we've done previously when we've calculated a normal probability, primarily using norm CDF. Also on this screen we've used inverse norm. Now you're going to scroll up. When you do, you will see 2 different commands that say binom. One says binom PDF. While this stands for probability distribution function, think of P as point. This line will do exactly what the formula does. Also, we will use this line that says binom CDF. The C stands for cumulative, and we will use this also. The P is for a single point when we're looking to find one value. This is just like the formula. The C will find a cumulative. It will find several values. Like if we wanted to know what was the chance of getting 3 correct or 2 correct or 1 or 0, we wouldn't want to do the formula multiple times. We would just use CDF. Let's first examine the PDF. Scrolling up to PDF, hit enter. Perhaps you have this kind of screen, perhaps you only have binom PDF in the parentheses. The first thing you enter are the number of trials. In this case we have 5 trials. That's our number of questions. Our probability, P, probability of success, is 0.2, a 1 in 4 chance of success. And our X value, the number of successes, we want to know what are the chance of getting exactly 1. And this should return that 0.395 or 396 number that we saw previously. Hit paste. There, if you have the binom PDF command, it goes open parentheses. It's n comma p comma the number we want correct, in this case X. There it is, 0.3955. So let's ask a similar question. What is the chance of getting, say, 3 or fewer? Well, we could do 3 and 2 and 1 and 0. We could do all that, or we could simply do the binom CDF. Second vars. Scrolling up to binom CDF. This time we have 5 trials. Our probability of success still 0.25. And we want to find, let's find 4. Okay. So this is going to be the chance of getting 4 or 3 or 2 or 1 or 0 correct, all those. I can hit paste. And we see it's 0.9990. So what that's saying is we have a 99.9% chance of getting 4 or 3 or 2 or 1 or 0. The only thing that wouldn't work is all 5 correct, and you could imagine we would have a very slim chance of getting all 5 correct. Almost 0.1%, 0.001. So binom PDF is for a single point. This is exactly the function that the formula is. Binom CDF finds a cumulative, a range from the number that you give it all the way down to 0.